Hello, this is Naz from NV Network Lessons. Hope everyone's doing okay and safe. This lesson is for my calculus lovers. We're going to solve another integral of exponent example. So these are the two rules. I think in my pretty much every lesson I've given on integrals of exponents, I've stressed that we need to basically make sure that we understand that e raised to the power x is indestructible function. In other words, if you take derivative of that or take integral of that, it's going to stay same. So remember that. So let's say we have a problem, x over e x square d to the x. This is indefinite integral. Why is it indefinite integral? Because I don't have a limit over here, right? So let's do some substitution. Let's say u is equal to x square, okay? If u is equal to x square, then du, change of u with respect to x, will be 2x. And I can say dx is equal to 1/2 over x. Just did some algebra, brought dx over here and brought 2x, actually 2x right here. So just did this algebra, that's all. All right, and so this is going to be dx and then du, okay? Du over 2x, all right? Remember this one, we're going to need it. Now what we can do is we can put use our substitution. We can say x over e x square. We said x square is equal to u, so we said eu, okay, e x over eu times, we're going to replace dx with du, which is right here, du over 2x. Agreed? Now this x and this x cancels. I can pull half out of the integral, then inside I'm left with e raised to the power u dot d over u. All right, make sure you understand that. So now what I'm going to do is I'm going to bring this in denominator upstairs. When I do that, it becomes negative, the exponent. So then I have 1/2 into e raised to the power minus u du, okay? Now I ask you, how can we solve this further? Because, you know, according to the rules, e raised to power something has to be positive before these rules apply right here. So, well, what we can do is we can do another substitution. Can we do another substitution? Well, I don't see why not. So let's do that. All right. So what we're going to do is we're going to say z is equal to minus u. You don't have to pick z. You can have a, b, c, d, whatever you want. I don't know, just z just came to my mind. So I just said z is equal to minus u. All right. So then I say dz with respect to du will be -1. Derivative of minus u. Agreed? All right. And then we can say dz is equal to minus du. All I'm doing is that bringing this du over here. All right. So now what we can do is we can do substitution back. We can say half, okay, and then e minus u is equal to z. We did the substitution and we said du is equal to, what is du going to be equal to? Minus dz, -1 dz. Because if dz is equal to minus du, and if I want to multiply both sides by minus, then dz is equal to minus dz is equal to du. Okay, so that's what I did, the substitution right here. Now what we can do is we can say bring this negative outside the integral, and then we can say ez dot dz. Now the problem becomes really easy because we know that integral of e raised to power x is just going to be ex. So that helps, that really does help. So then I do apply the integration and I get e raised to the power z plus a constant, okay? Then what I do is that I can go ahead and put the value back of z here, minus half e raised to the power minus u plus c. And then what I can do is I can put the value of u back in here. So minus half e minus x squared plus c. This is my final answer. So hopefully you followed it. We did double substitution in this. Remember that. We did double substitution in this. We substituted this x squared. We said, let's substitute that with u. Then we drilled down and we went down. And when we reached over here, e raised to power minus u, because that's not really helpful. I need something positive over there. Otherwise, I wouldn't be able to apply these rules. So then I said, okay, well, no problem. Let's say z is equal to minus u. And then we solved it. We found the integral, and then we substituted the values back. So that is it, my friends. This is an exam question. Watch it a couple of times. I hope you ace in your exam. If you do, please let me know. Thank you so much for watching. Have a nice day.